Hi, this is Qixuan, and today I'm going to talk about my project for this class. So let's begin. And this is a machine learning model for fetal surveillance by using the CTG data, which is the CTG is the cardiotography. This is a technique means of recording the fetal heartbeat and the uterine constraints during pregnancy. It is widely standard and widely used tool for fetal surveillance. So, due to the current situation we are going through, first I was trying to build a model for identifying the COVID-19 positive case but the thing is that I can't get access to the patient's medical data, which is protected by the government, and so there's no data for the public, so for public using. So I turned to this project, which I think is similar to the So basically the dataset have 23 attributes, including the baseline of fetal heart rate and the uterine contraction, which are an indicator of the fetal state. By monitoring these attributes, we can identify the heart condition of the fetal, and according to this attribute, the fetal state is identified as three classes: N, S, and P, where N represents normal, S represents suspect, and P represents pathologic. The model we create is going to get the input of the 23 attributes and identify the fetal state based on the data. And as I said, this model is easy to modify, and we can retrain the model for other diseases. So, and here is the agenda of the slides, and we will start with the architecture one, which is the blackboard architecture style, and we are gonna look at the component diagram, the class diagram, and the mapping between the component characters to the class. Then we will take a look at the second architecture style, which is the pipe and fleet architecture. And also is component diagram, class diagram, and the mapping. So after that, we will start with the pros and cons of each architecture style I found during this project, and I will choose the better architecture for this project, and I will give you the reason. And also I will talk about the reason why I choose this architecture and how I feel when I'm doing this project with this architecture. Actually, I implemented this project with these two architecture, and I found one of them the performance is better than the other one, and is easier to implement. So, and so here let's take a look at the first architecture, which is the blackboard architecture, and here is the component diagram. So, and we can see that all the components are connected to the data access port, and the data access port is connected to the blackboard, which the data storage stored, and the data access actually have no data, and the component is not directly deal with the data. It interact with the data through the data access port. And so at this point, we don't need to have multiple copy of the data. We just have one copy in the blackboard, and all the component processed on the same data copy, which means that the data is modified during the process, and each component can modify the data, which also means that only one component can modify the data each time. and the class, and so there's no support for concurrent execution because the data is only have one copy, and the component can only get access to the data each every time for one component. And this is a class diagram. So basically we have 6 classes, and each one of them contains the operation to modify the data. And here's a mapping between the component and characters to the class. And yeah. So, and let's talk about pipe and fleet architecture. So here is a pipe and fleet architecture, and the data flows between the component through the pipe. So as you can see, we have a two pipeline, which is two data flow. This is because that the original data set for the training data is different from the testing data set of the prediction. So we create a two pipe and fleet stream for two different functions. So actually we have two pipe and fleet here, one for training the model and one for prediction. So, and here is the class diagram. You can see there's a pipe. The pipe interface and the fleet interface basically have no implementation, and we have 6 classes implement the fleet interface, and the data process, the encode labels, the initialize with, and feed forward, and feed, and predict. So the input and the output of each implementation is basically the type, and each implementation have their own process to modify the data, such as the feed forward have add bias unit, cross function, and active function. And here is the mapping of component and characters to the classes of the pipe and fleet architecture. Yes. And here is the pros and cons of the blackboard architecture. So basically the advantage is that this architecture is widely used in AI system or machine learning model. So it is very it's very convenient to use this architecture, and the data flows fast between each component. So I think there's no data flow because what we are doing is applying different components on the data. So there's no data transmission. So and there's no need for data transmission overload. And I think it's pretty good. And another advantage is that the data stored in the blackboard, so we don't need additional space once we load the data into the blackboard. So it saves us some space, and also the process on the data is fast. Yeah. And but the disadvantage is that the component need to execute on order. So there's no support for concurrent execution because we only have one copy of data, so there is no support for concurrent execution. And we only have one copy of data, which means the original data is modified during the execution. So this may cause data mismatch sometimes, but it's very abnormal. And it's easy to find because to find out which component is created the mismatch, because you can just put a point through each component and execute each one of them, and you will find out which one create the mismatch. And here is the pros and cons of the pipe and filter architecture. The pros of the pipe and filter architecture is that the filter is reusable, and adding or deleting filter is very easy. So this makes the model retrain very easy. We can just exchange the filter and make the model suitable for other situation. And the operation on the filter could be executed concurrently under some proper situation. It is not always can be executed concurrently, but based on the situation, sometimes it can. And the most thing I like for the pipe and filter architecture is that the pipeline basically ignore the data type, so which saves a lot of time to deal with the data. But it still have some disadvantage. The first one is that the data transmission through the pipe creates a lot of transmission overload, which is very time-consuming when the dataset is large. And also, the data have multiple copies within the system, which increase the space needed. Although the component can execute it concurrently, it will create data mismatch and hard to debugging. One thing about training model is that it needs repeating some process multiple times, which makes the pipeline become very, very long. Like when you repeat the process like 10 times, your pipeline becomes 10 times longer than the original one. So also notice that the data within the pipe can have multiple versions, which makes some of the pipe difficult to implement. So consider all these pros and cons. I think the blackboard style is better than the pipe and filter architecture style for this project. I still prefer the blackboard style because it is very fast and when compared to the pipe and filter architecture, and it is easier to implement. And it don't need to allocate extra space for intermediate data because all we need is the final result of each epoch. So we just store the final result of each epoch. Then we are ready for the next epoch. And also, there's no data transmission overload during the process. And here is the code compilation, and so in order to train the model, I fit the model for 15 times for each parameter set, and I come up with the better result with the better parameter set. And here is the prediction accuracy. We can see that the predict accuracy of normal factor is 86%, and the accuracy for suspect factor is 83%, and the accuracy of the pathologic factor is 95%. So, and the whole prediction time is about 7 seconds. So that's it. I hope you enjoy it, and thanks for your time. And this is all my project about the machine learning model. Yes, and